All right, we're doing section 13.8. It's a little bit more trig stuff. We're going to do more graphing like we did yesterday, okay? This time, now what do we do? Let's just review real quick. Yesterday we did this. We said y equals what? A times the sine of b theta. All right? And what does the A represent? The amplitude. And what did the B? Well, it's not the period, but it helped change the period, didn't it? Okay, it's a coefficient in front of this x. I don't even know if they have it as like a specific word to use for that B, but it did. It does change the period. So how do we use that with the period?
360 divided by that number.
Right. So it's 360 divided by whatever that B is, right? And that's what the period is. Okay. All right. You follow me on that? Okay, so now we're going to change things around a little bit more. Let's go back in time a little bit. Do you remember doing this? My pen's acting weird again. I'm not sure what the reason is for that. No.
Is that a y?
It's y equals absolute value of x. Okay, do you remember doing this? What was the basic shape of this look like? A V. Remember that? It looked like a V. And we did some stuff to it. All right, we said, let's see.
2.
We did stuff like this. You wanted 2? Oh, it's not parentheses. I don't know. I said it's acting weird. We already discussed it. So it's x minus 2 in absolute value plus 3. Do you remember what this did to that regular V? This moved it at where? It moved it. I said moved it. Moved it. All right, so it moved it, how many? 2 places. Which direction? To the right. Okay, even though it's a minus, we discussed that. I'm not going to go through the whole reasoning behind it. Okay, we talked about it earlier in the year. So that moved it 2 places to the right. What did this plus 3 do to that whole thing? It moved it up. Okay, it moved it up 3 places. You remember this? So it's a shifting. We shifted it to the right. So horizontally, we shifted it 2 places, and this way is to the right. The minus means it's to the right. If it was a plus, then it would move it which direction? To the left. All right, this is plus 3. This is outside of the function. Do you see how this number is inside of the function, inside of the absolute value? That moves it left and right. When it's outside everything, when it's just being added to it, what did it do? It moved it either up or down. Now, if it moved it down, what kind of sign would this be? It would be negative. It would be minus. All right, everybody with me on that? Okay, so we're used to that. We did the same thing with a quadratic equation. Okay, it looks like a parabola, right? This is like the parent function. Remember that? And we changed this too. We could do the same kind of thing. Let's go like x plus 4. It's supposed to be a plus. Squared minus, let's say 1. All right. So what if we had something like this? Then what happened here? This moved it to the left 4 places. This was a parabola. It's not a V. It's not an absolute value. But still, the stuff inside here and out here did the same exact thing, didn't it? This moved it to the left 4 places, and this moved it, what? Down 1 place, okay? Now, what do you think I'm getting at here? We're going to do the same kind of thing, but with what?
Sinusoids.
Right, with sinusoids, with sine and cosine and tangent and the whole deal, okay? So we're going to do the same kind of thing, so watch this. We used a little bit, well, we didn't put any letters in here. I don't know, do you remember what letters they used for this? They actually used H and K, right, when they did that. Do you remember those? Right. We didn't really put the whole entire formula there very often, but we did talk about it a couple times. We used H and K for whatever reason. They use H and K. So let's do this. The A represents the amplitude, okay, how high up it stretches, right? It doesn't actually take it and physically move the whole graph up. It just takes the curve and it stretches it up higher or it stretches it lower, correct? That's what the amplitude does. And then sine B, and now what do you think we're going to change here? See, we went x minus 2, x plus 4. Theta is kind of acting like our x in these problems, so what can we do? Yeah, theta. Now let's write it as a general example. So we put minus, because we're taking the opposite side, right? The opposite sign. So we're going to write it like this. And then, right, then plus what? Okay. And there it is. So look at this. You know all this stuff. This right here is the amplitude. This right here affects our period, right? It's, excuse me. It's not exactly the period, but it affects our period. And we just talked about how to figure out what the period is from that number. What does this thing do right here? That moves it left or right, doesn't it? and this thing moves it what? Up or down. This thing right here, we say that it's a phase. I'm going to pause this after I finish this little part and try to fix my writing because it's acting kind of strange. So anyway, this is called the phase shift. This is really bugging me. I think I just have to restart the program. I might even have to restart the computer, and then it fixes itself. I'm not sure why it does this, but anyway, this is a phase shift. They call it a phase shift, or you could call it a horizontal shift if you wanted to. Okay, this moves left or right. Now, if it's a minus, it moves it to the right. If it's plus, it moves it to the left because it's minus a negative, right? So minus a negative, the negative means it goes to the left. You got it? This we call just a vertical shift. Vertical shift. This is really disconcerting because it's, when I write, it writes at a big delay and it's kind of a pain. And a vertical, put a little period there. Okay, that's the vertical shift, which means it just moves it up and down. Does that make sense? All right, and that's what's going on. So that's what we're going to mess around with today. We're going to move it left and right. Now, what does it do? It doesn't stretch it. What stretches it? The period stretches it, doesn't it? Left and right. It makes it either, it compacts it or it spreads it out a little bit. What does the phase shift really do? It actually picks it up, right, and then places it so far from wherever it originally was, right? And left or right. This would be an angle right here, okay? So you could move it 45 degrees, 90 degrees. It could be any degree at all, but we're going to stick with our basic ones that we know, all right? And this moves it, it actually picks it up. It doesn't stretch it. It physically picks it up and moves it either up or it moves it down. That's what the K does to it. All right, so now when you see an equation, a sinusoid with numbers all throughout here, you should be able to look to see where they are, and that tells you what it does to that original graph. Our original parent function would just be y equals sine of theta, correct? But look at all the different things that you could do. 4 different things that you could do to change this. You could even put a negative, right? Depending on positive or negative, that could change it as well. All right, so there's a ton of different things you can do to mess around with your original y equals sine theta graph. You got it? Okay, but basically today, we already learned the amplitude. We already learned how to do the period. So basically, and we learned the plus or minus. So basically, only thing new we're learning today is the phase shift and the vertical shift. All right, let's go on to the next video, and I'll try to restart this again.